Good day, engineers! Para sa video natin ngayon, ang i-discuss natin will be sample problem number 2 for the analysis of doubly reinforced beam. Simulan natin yung video by knowing what is stated in the problem. Sabi dito sa problem number 2, an exterior beam is designed to resist a positive moment and has a dimension of 350 mm by 500 mm. This beam will be reinforced with 6 diameter 32 mm bars as tension reinforcement and 2 diameter 20 mm bars as compression and diameter 12 mm stirrups. If F'C is equal to 28 megapascal and the Fy is 414 megapascal, we are asked to determine the depth of compression block, the net tensile strain, and the ultimate moment capacity ng beam na given. So, to start, syempre, coming from the problem itself, hindi sinabi kung ano yung layout nung 6 na diameter 32 mm bars na tension reinforcement. So, we would like to check if that is a single layer or a 2-layer reinforcement. So, para magawa natin yon, we have to check for the clear spacing of the bars. So, syempre, to check for the clear spacing of the bars, ang una natin gagawin is to determine ano yung minimum spacing. So, sa minimum spacing, ang criteria na sinasabi ni NSCP is, so zoom in lang natin. Sabi doon, ang first criteria for the minimum spacing is equal to the 4/3 diameter of our aggregate. Let's say hindi stated sa problem what is the diameter of our aggregates. So mostly sa construction, ang ginagamit natin is the 3/4 inch na diameter of our aggregate. So if di stated sa problem, we would use the 3/4 inch diameter. So for example, sa problem na to, syempre, gamitin natin yung 3/4. So, that is 4/3 times the 3/4 inch. So, that will be a value 1 inches. Kasi nag-cancel out. So, 4 and 4, that will be 1 inch. So, approximately 1 inches is equivalent to 25 mm. So that is the first criteria for our minimum spacing. The next one will be S minimum is equivalent to a value which is 25 mm na exact value. The third criteria will be S minimum should be equivalent to the diameter of our bar. So the diameter of our main bar is 32 mm. So for this one, we will have the 32 mm diameter bar or 32 mm na minimum spacing kasi sabi ni code, kunin daw yung greater or greatest of the three. So, our minimum spacing coming from the criteria of the NSCP is 32 mm. Now na nakuha na natin yung minimum clear spacing for our reinforcement, we would now like to check kung ano yung magiging layout ng 32 mm bars dun sa beam natin. So, to check, syempre, the clear spacing of the bars will be equivalent to B. So, ito ginamit na natin from our previous video. B minus dalawang clear cover minus 6 na diameter ng stirrups minus N minus 1 times the diameter of the bar divided by N minus 1. So we would like to substitute this one or yung mga given values natin to this equation. So let's say ang tinry natin or inassume natin na single layer yung reinforcement. So to check the spacing, we have the base, which is 350, minus dalawang clear cover, which is, sabi dito, that is an exterior beam. So our clear cover will be equivalent to 50 mm. So that is 2 times 50. Then the diameter of our stirrups will be diameter 12. So that will be 6 times 12. Minus, since we will try a single layer, so ibig sabihin, pipilitin natin ipasok yung 6. So that will be, ang n natin is 6 minus 1. And the diameter of our main bar is 32 mm. So that will be 6 minus 1 times 32. Then divided by, so that is 6 minus 1. So our clear spacing from this equation will be equivalent to 18 over 5 or approximately that is 3.6 mm. So as you can see, this is far lesser than our minimum spacing, which is the diameter 32 or the 32 mm spacing. So therefore, hindi natin siya pwedeng pagkasyahin ng isang layer. We will have to use 2 layer of reinforcement, which is tigatlong diameter 32 per layer. So we have 2 layers of reinforcement for the tension side. So check natin kung papasok yung assumption na yon. So assume 2 layers and sabi 3 diameter 32 per layer. So let's check from the clear spacing. So that will be S is equal to 350 minus 250 minus 6 na 12 minus 6 minus 1 or 3 minus 1 rather, kasi that is tatlo per layer, times 32 divided by 3 minus 1. So our clear spacing from this equation will be equivalent to a value of 57 mm. Ito ngayon yung clear spacing natin, which as you can see is greater than our minimum spacing, which is 32 mm. Therefore, okay yung spacing na natin and we can assume 2 layer of reinforcement. So for this given example, hindi na natin i-check yung part ni compression bar kasi malamang sa malamang papasok yan and we have 2 diameter 20 mm bars as compression. Pero ang minimum spacing nito is malamang 25 mm lang kasi ang bar diameter niya is 20 mm. So sorry, ang minimum clear spacing niya is 25 mm. So kasi ang diameter ng bar niya lang is 20 mm. So the greatest of the 3 requirements will be 25 mm. So ang clear spacing lang na kailangan nitong i-satisfy yung compression bars natin is 25 mm. Pero hindi na natin siya i-check kasi malamang papasok naman siya kasi yung tatlo nga na diameter 32 pumasok. What more yung dalawang diameter 20. So after we have produced the layout of the reinforcement, so kunin natin yung drawing natin dito. So magiging ganito siya. And we are now ready to produce some properties like the still area of the tension reinforcement, the still area of the compression reinforcement, the effective depth, uh, the concrete cover of our compression reinforcement, and the distance from the extreme compression fiber to the farthest reinforcement, which is D sub T. Unahin natin munang kunin yung part ng steel area for the tension reinforcement. So we have AS, which is equivalent to, so 6 na tension reinforcement na diameter 32. So that is 6 times pi over 4 times the 32 squared. That is equivalent to a value 1536 pi or 1536 pi. Next value na kukunin natin will be the compression steel area, which is A prime S. So that will be 2 times pi over 4 times 20 squared. So that will be equivalent to 200 pi. Now na nakuha na natin yung mga steel area, next natin kunin is yung mga effective depth, yung concrete cover, at yung DT, which is the distance from the extreme compression fiber of the concrete to the farthest reinforcement. Start tayo dun sa effective depth. Yung effective depth natin, syempre, yan yung distance from the extreme compression fiber of the concrete to the centroid of our tension reinforcement. So, ibig sabihin, mula yan dito sa centroid, papunta dun sa extreme compression fiber ni concrete. So, yun yung D. Ngayon, ang centroid ng reinforcement natin at tension is, kahit hindi natin isolve, alam natin na nasa gitna yan. Kasi equally distributed yung bars on the first layer, 3. Tapos on the second layer, 3 din. So, equal yung distribution nila. And we can say na ang centroid nila is nasa gitna lang. So, we have here, syempre 32 mm bars to. Tapos ang spacing in between them, kasi kapag sa construction yan, ang gagamitin mong spacer is kung ano yung bakal na ginamit mo for tension. So, ang spacer niyan is 32 mm din. Then, ang diameter ng bar dito will be 32 mm yung nasa second layer. So, as you can see, pwede ngayon natin gamitin yung pinakagitna lang nitong mga values na to para i-subtract dun sa height nung reinforced concrete beam natin. So, that will be, ang effective depth natin ngayon is yung height na 500, bawasan natin ng clear cover, which is 50, tapos ibawas natin yung stirrups, which is 12, tapos bawasan natin ng isang bar na 32. So, nandito na tayo. Tapos, syempre, kung gigitna natin yan, ang kukunin natin will be, i-deduct natin yung 32 over 2. So, from this equation, we can get a value of the effective depth, which is 390 mm. Yan na ngayon yung effective depth natin. Now, let's proceed dun sa concrete cover nung compression reinforcement, which is D prime. So, that will be 500 or 50 lang plus 12 plus kalahati ng bar niya, which is 20 over 2. So, para lang natin inad yung clear cover, yung stirrups, at yung kalahati nung diameter ng bar. So, that will be a value 72 mm. For the next one, we could have yung DT. Si DT, siya yung distance from the, so dito na lang natin lagay para kita natin yung figure. So, si DT, yan yung distance mula dun sa extreme compression fiber ni concrete papunta dun sa farthest reinforcement, which is the first layer reinforcement. So, ang DT natin, ito yan. Wala dito hanggang dito. So, yan yung DT. So, since yan yung DT natin, we just have to deduct. So, yung 500 na height, bawasan natin ng 50, bawasan natin ng 12, at babawasan lang natin ng kalahati ng bars, which is 32/2. And this one will give us a value 422 mm. So, ito na ngayon yung ating mga properties or yung iba pang properties na pwede natin gamitin to get some values of the required. So, after getting these values, proceed na tayo on determining whether we will analyze this given beam as singly or we will just analyze this as a doubly reinforced. Hindi basta-basta na pag nakakita tayo ng compression bar sa taas is ang gagawin na lang natin is ayan na siya. Isosolve mo na siya as doubly. No. You have to prove that this one is doubly reinforced before going through the process of analyzing it as doubly reinforced. So now to check, una nating kunin yung actual steel ratio, which is equivalent to a value AS actual or the AS alone divided by BD. So from our example, we have an AS of 1536 pi. So that will be divided by B, which is 350, times the effective depth, which is 390. So our raw actual will just be equivalent to a value 0.035 times 352 or 0.035352. So ito ngayon yung actual steel ratio natin. Then kailangan natin tong i-compare dun sa maximum steel ratio of a singly reinforced beam. So yung raw max na yon is nade-derive natin using this equation or using this diagram, yung strain diagram natin, assuming that this side is 0.005 or yung net tensile strain is 0.005. So dito sa problem natin na to, hindi ko na siya i-derive because on some parts of the videos or on the other videos, i-derive ko na siya. So for this video, direct na lang natin yung maximum steel ratio. So the maximum steel ratio na equation is equal to 3/8 times 0.85 F prime C beta 1 over the Fy times dt over d. So ito na ngayon yung maximum steel ratio natin. So substituting the values, we could have 3/8 times 0.85 times 28 times beta 1, which is 0.85 kasi 28 lang yung F prime C natin, divided by 414 times 422 over 390. So our maximum steel ratio coming from this equation will be equivalent to 0.019828. So this is the maximum steel ratio, and as you can see, this is lesser than our raw actual. So our assumption or our beam will be a doubly reinforced beam. So ngayon, ito na ngayon yung magiging basis natin, and we can now analyze or proceed in analyzing a doubly reinforced beam. So to analyze a doubly reinforced beam, syempre kakailanganin natin ito, yung stress diagram coming from our concept of the analysis of doubly reinforced beam. So, syempre, meron tayong first stress diagram, sa kanya manggagaling yung first nominal moment. And this one is in the second stress diagram, sa kanya manggagaling yung second nominal moment. So, from this one, since doubly na siya, we have to assume the yielding of the bars. So, for this example, we first try to assume compression still does not yield. And our tension still yields. So, kahit ano yung gawin yung assumption is pwede as long as kapag na-prove nyo or nakita nyo na mali yung assumption, you have to correct it along the way. So, now, we can use the static equation coming from these two diagrams. So, that is a static equation which is C1 plus C2 is equal to T. So, pinagsama lang natin yung T1 and T2 kasi parehas naman yan na coming from the tension reinforcement itself. Para maiwasan na natin yung paglalagay ng AS1 at AS2. So, coming from this one, we have AC1. So, galing dito sa compression block. So, that will be 0.85. That is F prime C AB plus we have yung C2 galing sa compression reinforcement which is A prime S, and we assume that the steel does not yield. So that will be isasalpak na natin yung equation dito ng F prime S which is 600 times C minus D prime over C minus 0.85 F prime C. That is equal to AS, and our yields, our steel stress will be Fy since we assume that our tension still is yielding. So next one, since hindi natin pwedeng ma-solve yung ganitong klase ng equation kasi dalawa yung unknown variables. So, let's try to have another equation which is yung A, pwede natin siyang gawing beta 1 C. So, substituting, we have 0.85 F prime C beta 1 C B plus. Pasok na natin yung A prime S tsaka yung 600. So, that will be 600 A prime S C minus 600 A prime S D prime. So, that will be over C minus 0.85 A prime S F prime C. That is equal to AS Fy. From this one, we could multiply both sides of the equation to C so that we could have an equation 0.85 F prime C beta 1 B C squared plus, so dito sa part na to magka-cancel out yung C, so that will be 600 A prime S C minus 600 A prime S D prime minus 0.85 A prime S F prime C C is equal to AS Fy C. So, Combining similar terms, so syempre si ASFY kailangan nating i-transpose papunta dito sa kabila. So we could have an equation 0.85 F prime C beta 1B C squared. Tapos pagsamahin natin yung may mga variables na C. So that is 600 A prime S. Tapos si minus 0.85 A prime S F prime C. Minus si ASFY. That is C. Minus natin yung 600 A prime S D prime. That is equal to 0. Now, yung first term, which is ito, that should be A. Tapos, itong part na to will be B. Then, ito, kasama yung negative sign, will be value big letter C. So, hindi yan yung C na unknown sa atin. So, we could use the quadratic equation or quadratic formula in finding the value of our unknown, which is C, yung small letter C. Or we could use the function of our calculator na nagsosolve ng quadratic equation. So, syempre, kung alin yung acceptable value of our C, kasi at times, calculator, since quadratic yan, it will give you two answers. At times, it will give you one positive and a negative value. So, dun tayo sa positive value na ilalabas ni calculator. So, solving this one, we could have the value of A, which is 0.85 times 28 times 0.85 times 350, which is equivalent to 14,161 over 2. So, yan na ngayon yung A natin. Our B will be equivalent to a value 600 times A prime S. So, that is 600 times 200 pi minus 0.85 times A prime S is 200 pi times the F prime C is 28. Then, we have to deduct ASFY. AS is 1536 pi times 414 megapascals. So, our B will just be equivalent to a value negative 1,635,714.197. So, that will be a value B. And the big letter C will just be equal to a value negative 600 times the A prime S, which is times 200 pi multiplied by D prime, which is 72 mm. So that will be equivalent to a value negative 27,143,360.53. So, yan na ngayon yung tatlong coefficient natin. So, solving this one using quadratic equation or quadratic formula rather, and the function of our calculator, we could produce the value of the small letter C, which is equivalent to 246.5646 mm. Then, yung A natin dyan will be equivalent to beta 1C, so that is 0.85 times the value 246.5646. So that is just 209.5799. Ito na ngayon yung ating C and A. Now we have to verify our assumption kung tama nga ba na inassume natin that compression still does not yield and tension still yields. So unahin natin yung part ni tension steel. So the tension steel stress will be equivalent to 600 times D minus C over C. So that is 600 times the effective depth, which is 390, minus C is 246.5646 divided by 246.5646. So RFS now will be equivalent to a value 349.0413. So that is in megapascal. And this is lesser than our Fy. Therefore, our steel does not yield. So yung assumption natin on the part of the tension is mali. Since ang inassume natin is tension steel yield, so we have to correct that one. Check din natin yung compression. So for our compression, F prime S, so that is equal to 600 times C minus D prime over the C. So that will be equivalent to 600 times the value C, which is 246.5646 minus D prime is 72 divided by 246.5646. Coming from this one, we could have the F prime S equivalent to 424.7924. And from this one, we could say that this is greater than the Fy, therefore steel yields. Mali din ngayon yung assumption natin on the part of the compression side. Now, let's correct the assumptions. So, to correct the assumption, so, assume compression steel yields, tapos yung tension steel natin does not yield. And then we can have ulit yung statical equation C1 plus C2 is equal to T. So same values, si C1 natin is 0.85 F prime C AB. Syempre si C2 natin magbabago, A prime S. Ngayon, since assumption natin is compression steel yields, so we have Fy minus 0.85 of our F prime C. That is equal to a value, yung T natin is AS. Since ngayon, the tension steel does not yield, we could have, salpak natin yung equation for the steel stress or tension steel stress, that is 600 times D minus C over the C. So, same procedure, we have to substitute A is equal to beta 1 C. So, ang resulting equation natin will be, that is 0.85 F prime C AB plus A prime S Fy. So, pasok na natin yung mga variables. Minus 0.85 A prime S F prime C is equal to, so, pasok na natin si AS and si 600. So, that is 600 ASD minus 600 ASC divided by C. Now, we have to multiply both sides by C. So, multiply natin parehas by C. So, we could produce an equation 0.85 F prime C AB or beta 1. Sorry, hindi natin nailagay. So, this is beta 1 CB. So, that will be 0.85 F prime C beta 1 B C squared plus, so, A prime S Fy times C minus 0.85 A prime S F prime C. May variable na siya na C. That is equal to, syempre ito magka-cancel out lang to. Then that is 600 ASD minus 600 ASC. Then after that, combine natin yung similar terms. So to combine the similar terms, so that is just 0.85 F prime C beta 1B C squared. So combine natin lahat ng may variables na C. So that is A prime S Fy minus 0.85 A prime S F prime C. Tapos ito magiging positive kasi itatranspose natin. Itong part na to magiging positive kasi itatranspose natin siya. So that will be plus 600 AS. Then may variable sila na C. Then ito will become negative, so that is minus 600 ASD. So that is equal to 0. So syempre this part should be A. This part should be letter B, and this part should be our big letter C. So getting the values of those coefficients, we have A is equal to 0.85 times 28 times 0.85 times B is 350. This is same as the previously calculated value, which is equivalent to 14,161 over 2. Then for our letter B, that will be equivalent to 200 pi times 414 minus 0.85 times 28 times 200, or rather that is times 200 pi. So that is yung 0.85 A prime S F prime C plus yung 600 times the AS, which is 1536 pi. So the value of B will be equivalent to 3,140,461.68. So yan ngayon yung coefficient natin for B. And the coefficient for C will be negative 600 times our AS, which is 1536 pi times 390. So that will be equivalent to negative 1,129,163,798. So using the function of our calculator for quadratic equation or the quadratic formula, we could get an acceptable value of small letter C, which is 235.0208. From this value, we could get the depth of compression block A, which is equivalent to beta 1 of C. So that is 0.85 or 85% of C, which is 235.0208. And the value of A from this one will be 199.7677 mm. Now we have to check yung values natin of Fs and F prime S. So for the Fs, we have here 600 times D minus C over C. So that will be 600 times D. So that is 390 minus C. So that is 235.0208 divided by 235.0208. So RFS now will just be equivalent to a value 395.6566. This is in megapascal, and this is lesser than 404 or 414. So lesser than siya ng Fy. So therefore, the assumption is correct that still does not yield for the tension. For our compression, so that is F prime S is equal to 600 times C minus D prime over C. So that will be 600 times the C, which is 235.0208, minus D prime is 72, divided by 235.0208. So our F prime S coming from this one will be 416.1865, which is greater than 414 megapascals. Therefore, our steel yields. So ngayon, correct na yung assumption natin for compression and tension. Mamaya ipapaliwanag natin bakit naging ganyan yung behavior nung reinforcement natin. So, kunin muna natin yung required. So, nakuha na natin yung isang required kasi ang tinatanong dito, the depth of compression block. Since napalabas na natin yung true value or yung correct assumption, ito na ngayon yung ating depth of compression block. So these are the true values now of A and the true values of C. So next nating hanapin is yung net tensile strain. To get the net tensile strain, syempre kakailanganin natin yung epsilon sub T. And that epsilon sub T is manggagaling sa strain diagram natin. Which is, ang gagamitin natin is, so, meron kang ganyan, yung strain diagram natin. And we have to use 0.003 dito, and this is epsilon sub T. Then, manggagaling yan dun sa farthest reinforcement, which is dt. And this one will be C. So, dito manggagaling ngayon yung ating epsilon sub T, and that will come from similar triangles, which is ito, yung height ng triangle sa baba is dt minus C. So, from similar triangles, we could have, so that is the first triangle, yung C, itong nasa taas. Ito. So, that will be C over 0.003. That is equal to a value epsilon T or dt minus C muna over epsilon sub T. So, yan ngayon yung ating ratio and proportion or the similar triangles. Now, arranging the term, we could have epsilon sub T is equal to 0.003 times dt minus C over C. So, ito, dinala lang natin doon. Ito, dinala natin dito. And itong value na to is ibinaba natin. So, that will be epsilon sub T now is 0.003 times dt minus C over C. So, substituting the value here, we could have 0.003 times the dt, which is 422, and minus 235.0208 divided by 235.0208. So, double check lang natin yung values. So, 235.0208. So, the value of epsilon T coming from this equation will be equivalent to 0.002387. As you can see, this is a non-ductile behavior and this is in the transition zone. Kasi this is lesser than 0.005. Kapag nasa design part tayo, we cannot allow this epsilon sub t kasi mas mababa pa siya sa 0.004. And the minimum requirement for a beam kasi is 0.004. So we cannot consider this as a beam kung nandun siya sa design part or dun sa design process ng beam natin. So, since ang tinatanong lang sa atin is yung mga moment capacities niya at net tensile strain, continue lang natin yung solution. So, to get our strength reduction factor, gagamitin natin ngayon tong epsilon sub t. But first, we have to get epsilon t sub y. Epsilon t sub y will be equivalent to a value 414 divided by 200,000. Now, this value will become 0.00207. Ito na ngayon yung epsilon ty. So, ngayon, since sinosolve natin yung problem or sinosolve nyo yung problem, wala kayong hawak na NSCP. So, kung wala kayong hawak na NSCP at hindi nyo kabisado yung equation for the reduction factor, we have to use yung reduction factor and the net tensile strain diagram, which is ito. So, we can derive the equation for the reduction factor by using the slope and y-intercept form of the line. So, syempre, ito siya kasi dito papasok yung beam natin. So, kaya din natin kinuha si epsilon t sub y kasi magiging malaki yung tulong niya for our beam. So, syempre, we will have 2 points of this line, ito at ito. So, from this one, this coordinate will be corresponding to epsilon ty, which is 0.00207 and 0.65 as y. And this point will correspond to 0.005 and 0.9 for the y-axis. So, una natin kunin yung slope of the line, which corresponds to m is equal to rise over the run. So, yung rise natin dyan will be 0.0 or rather that is 0.9 minus 0.65. Yung run natin dyan is 0.005 minus 0.00207. So, para lang tayong gumawa nung triangle na yung height nito at yung base. So, our slope coming from this one will be 25,293. Now, we are ready to get the y-intercept. So, galing sa slope-intercept form, which is y is equal to mx plus b. So, let's assume that y, kuha tayo ng isang point. Etong point na to yung gamitin natin. So, that is equal to 0.005 or 0.9 rather. So, y is equal to 0.9 and x is equal to 0.005. So, substituting these values and the value ng slope, we have 0.9 is equal to 25,000 over 293 times 0.005 plus b. So, arranging the term, we have b is equal to 0.9. Idededuct mo ngayon yung 25,293 multiplied by 0.005. The answer will be equivalent to 1387 over 2930. Ito ngayon yung ating y-intercept. So, after getting the y-intercept, meron na ngayon tayong equation of our reduction factor, which will correspond to, syempre, ang y natin yung reduction factor. So, y is equal to, ang slope natin is 25,000 200 over 293. So, ang x natin is yung epsilon t and plus yung y-intercept natin which is 1387 over 2930. So, substitute natin yung value ng epsilon sub t na nakuha natin kanina. So, that will just be equivalent to 25,000 divided by 293 times the epsilon sub t which is 0.002387 plus 1387 over 2930. Our reduction factor now will be equivalent to 1587 over 2344. Ito na ngayon yung ating reduction factor. So, para makuha naman natin ngayon yung moment capacity or the ultimate moment capacity na kailangan natin yung stress diagram na dalawa kanina. So, kunin natin yung stress diagram. Ito. So, syempre, getting this one, we could now produce our nominal moment. So, syempre, dun sa first diagram, sa kanya manggagaling yung first nominal moment. And it has a moment arm d minus a over 2. Second nominal moment will come from this second diagram, which is ang moment arm between the two is d minus d prime. Since this is an analysis problem, we will get the value of our moment coming from the compression side. So, sa Mn1, gamitin natin yung compression. So, that will be C1 times D minus A over 2. So, ang C1 natin is 0.85 F prime C AB times D minus A over 2. So, substituting the value, we have here 0.85 times 28 times yung value ng A natin, which is 199.7677 times 350 times 390 minus 199.7677 divided by 2. This should be multiplied by 1 over 1,000 squared para maging kilonewton meter yung ating answer. So, the first nominal moment is 482.7721. This is in kilonewton meter. Now, the second nominal moment. Our second nominal moment will just be equivalent to a value A prime S times. So, syempre, yung compression steel natin is, sabi natin dito, nag-yield. So, ibig sabihin, Fy yung gagamitin natin. So, that is Fy minus 0.85 of F prime C times D minus D prime. So, substituting the values, we have 200 pi times Fy is 414 minus 0.85 times 28 times D, which is 390, minus D prime is 72 times 1 over 1,000 squared. So, our second nominal moment will be equivalent to 77.964 kilonewton meter. Now, adding the two moments, we have Mn is equal to Mn1 plus Mn2. So, ito yung paraan para makuha natin yung total nominal moment capacity ng beam natin. So, the nominal moment capacity or the sum of these two will be 560.7361. That is in kilonewton meter. Now, para makuha natin yung hinahanap na ultimate moment capacity, so that will be reduction factor times DMN. So, ang reduction factor natin is yung 1587 over 2344 multiplied by the nominal moment 560.7361. So that will be equivalent to a value, so that is mu, which is 379.6451 kilonewton meter. So ito na ngayon yung required sa problem natin, and yung net tensile strain na hinahanap. So the net tensile strain is ito. So for now, that is all for this video. We will be having the second part of this video to compute some other matters regarding doubly reinforced beam. So again, this is Engineer Rodolfo. Thank you for watching, and don't forget to subscribe to Butch TV.